All right, folks, it's Bass Action, back in action here. In this video, we are going to look at how to graph our tangent functions. In the next video, we'll look at cotangent. What we're going to do is we're going to start off by unwrapping our unit circle for the tangent graph. Now, we've watched some videos already for how the sine and the cosine graphs unwrap and create the sine and cosine curves. On tangent and cotangent, it's actually a little easier if we just look at some evaluating and we can kind of visualize where some of our key numbers are going to come from. So quickly going through our values here at the top, thinking we're going to evaluate tangent at each of these angles. So tangent of a negative pi over 2 is going to be undefined. Tangent of a negative pi over 4 is a negative 1. Tangent of 0 is 0. Pi over 4 is 1. Pi over 2 is going to be undefined again. Those are going to be important for us. 3 pi over 4 is going to be our negative 1. Pi is 0. 5 pi over 4 is 1. And 3 pi over 2 is undefined. Now, if you need, you can go ahead and pause this because I did just go through those very quickly. Now, what we want to do is we want to look at these values here and compare it to these graphs that we've been referencing since we first introduced what our parent trig graphs would look like. Anywhere that we have these undefined, remember, vertical asymptotes happen when a function is undefined. So anywhere we had an undefined value, it created a vertical asymptote for us. The other thing that we can draw our attention to are these places where the tangent function evaluated to 0. And sure enough, tangent was 0 at 0 and tangent was 0 at pi. So those values there also connect. Now, I haven't included a graph here that has as much detail to include these halfway values, but we can actually identify these negative ones, 1, and negative and positive ones by looking at these values right here. Each of these would, in fact, correlate to the kind of a horizontal t-chart that I've got up here. So hopefully this t-chart up here helps you understand the shape of our tangent graphs a little bit more. Now, as always, we don't want to have to make great big t-charts every time we want to do a graph. We want to have a little bit better process to help us create our graphs. So much of our work here is going to be similar to what we did for our sine and our cosine, and thus our secant and our cosecant. We are going to be able to find our vertical translation in the same place. Notice on this one I put the +2 on the back end, even though we often see it on the front. That part doesn't matter, its location. So this graph is going to be shifted up 2. Now, to draw in our horizontal line here, it's going to be a little bit more awkward, but we could go ahead and draw in. I'm just going to make it really, really small here to remind ourselves that when we're counting, we want to count from there and not from our x-axis. Our vertical stretch is going to be how much it is going to be stretched. We don't call it an amplitude for a sine and a cosine graph, but we can, or for a tangent graph or a cotangent graph, like we do with our sine and cosine, but we find that vertical stretch value in the same place, and it's going to be right here in the very front. So since it's just a coefficient of 1, we can say that there is no vertical stretch on this one. There's also no reflection. A reflection is going to be found in the same place as well. If there was a negative there in the front, there would be a reflection. So there's no reflection here. Now, our period, this is where it gets really important for us to understand. Notice that the distance between the asymptotes on this one period of tangent, the distance between these asymptotes is pi. So this is a place where students often make mistakes on a tangent function because how we find our period is going to be a little different. Our period is now going to be pi divided by whatever our coefficient is. Notice that our period change and our phase shift are mixed together, but we can find that amount of the period change by looking at that coefficient still. So now we're going to do a pi, not 2 pi, divided by this 1/3. Of course, pi divided by 1/3 is the same as pi times 3, so our period is now going to become 3 pi. Now, when we're thinking about trying to find our first asymptote, what we're going to ask ourselves is, how does this move? Now, we're going to write the question, then I'm going to explain what the this is. How does this move? And what I'm talking about is we're talking about these asymptotes that we're looking at on this parent function. Now, I like to try to move this positive pi over 2 asymptote. Some people like to move this negative pi over 2. I want to call your attention to the fact that I'm not moving this value right here at 0, 0, because this value right here is in the middle of an actual period. So I want to be able to move an asymptote so I can create full periods of tangent. It's just going to make a little cleaner graph for us. So what we're going to do is, oops, I moved that too far there for you. What I'm going to do is we could either take this entire expression and set it equal to pi over 2, or what we've been doing up until now is we could factor out that period change, and I could rewrite this, factoring out that 1/3, and rewrite it as 1/3 times x plus pi over 2. Of course, if we distribute that 1/3, we'll get back to the original. Now, if we have this separated out, we could just take this amount. Often there's a temptation to say, oh, I'm going to shift by pi over 2, and that's true, but what is handy is to actually write this out. We're going to take this x plus pi over 2, and since we're trying to move the pi over 2 asymptote, I'm going to set it equal to pi over 2. And what that shows me when I solve for x is I can simply make my first asymptote at 0. And that's pretty handy for us. That's going to make our graphing a little easier. Okay, so it's almost going to be like then graphing straight from right there. Okay, so I'm going to make that first asymptote right there. Now, the next thing that we want to do is we want to find the distance between our key values. And we're going to take our period, we'll divide it into 4 pieces. That'll give us a little more detail than my graphs up above. So my period was 3 pi, and I'm going to divide that into 4 pieces. So now I'm going to start with my first asymptote at 0, and I'm going to add to that 3 pi over 4. And we've talked about this before. Our graphs go in each direction, so in case we need it, we could make this a plus or minus. So we could add that 3 pi over 4 in either direction and create our graph. Now, I'm going to make each then of my little tick mark values worth 3 pi over 4. That's going to just be the easiest notation for us here. So we'll get a 3 pi over 4 for the first point, and then we're going to add another 3 pi over 4. That's going to give me a 6 pi over 4, then a 9 pi over 4, and a 12 pi over 4. Of course, we can reduce these. We've been doing these on our graphs all along. This will reduce to a 3 pi over 2. This will reduce then to a 3 pi. And what that does nicely show us is that from where we started to where we stop is the period that we wanted. So now, when I go to graph this, what I'm going to do is I'm starting here. Remember, we're going to work on this shift, and we don't have a vertical stretch, so I'm just going to go up our 1. So from here, I'm going to go over 1, and looking at the parent graph from up above, I'm going to go down 1. Then, referencing that parent graph from up above, I'm going to need my next point to be right on what would be considered the x-axis, but we've shifted it up. Then I'm going to go over 1 more, and I'm going to go up 1. And then I'm going to go over 1 more, and I'm going to put in another asymptote. What that's going to do is that's going to give me my nice tangent graph, and I'm going to connect this so it's going to go up and approach the asymptote, and it's going to come down and approach the asymptote. Now, oftentimes we want to do another period of tangent. Oftentimes we do 2 periods of tangent, so we could go in the other direction, and I could think of that then as I'm going to go back 1 and up 1 because I need it to follow that pattern, and then I'm going to be on, and then I'm going to be down, and then I'm going to have an asymptote. because we're adding a little more detail than what the parent graph that I had drawn up above looks like. So there we go. And then if we wanted to label these, we could in fact label our points. We could label this as a 3 pi over 4 to indicate how we were counting. Then we would indicate our 3 pi over 2. If you want, you can even draw it up here so it's not in the way. I could put my 9 pi over 4, and then I could put my 3 pi. If I wanted to go in the negative direction, I would say a negative 3 pi over 4. Now I'm counting in the negative direction. And I could continue marking all of those as well if I wanted, or if your teacher required that. So that's going to be our tangent graph. Oh, real quick, let's not forget the domain. So our domain is going to be x such that x is not equal to, and similar to our secant and our cosecant, we're going to grab an asymptote. Certainly we have an infinite number of asymptotes, but boy, this asymptote here at 0 is going to be the cleanest and the easiest. So this is going to be an asymptote. It's always good to keep in track of this. And then we want to know the distance between the asymptotes, and this is different than the secant and the cosecant. This is actually going to be the period this time. And then we're going to put our k to help us be able to predict all of our future asymptotes. And then the range for all of our domain functions is negative infinity to positive infinity. All right, so that's all we've got for tangent, and then we'll do cotangent on the next video.